Hello everyone. So today we have a problem statement called panagram. What is panagram? First of all, we have to discuss it. So basically, we will be given one string and we have to check that if it contains all the letters or not. That's it. So if you see at the very first string, we have A, B, G, C, X and Y. This doesn't contain all the letters, correct? So that's why we will return false. Okay, basically our output will be false. If we check the next string, check thoroughly that you will see that we have all the letters in this particular string, correct? So that's why we are returning true. And similarly, you can check the third input as well. Okay, so it doesn't contain all the character, that's why we are returning false. And there is one note here, that is the string could contain special character like underscore, okay, percentage, okay, ampersand, anything. It could contain any special character, and it could contain under uppercase as well as lowercase. It could contain a mix of those. Okay, so this is the note we have to take care of. So now let's proceed further and try to solve it. So let's say we have one string called, let's say it has A, B, one underscore and one small c. So if we put it in a array like structure, it will be like this. Okay, so we put it in a array like structure. Now how we can solve it? One thing first we can do, like we will check the length of the given string. Okay, we can check like if the length is less than 26, because we know in English we have 26 letter. So first we'll check if the length of the string itself is less than 26, then we'll directly return false. So we can check, like first we can do first step, like check length of the string. If it is less than 26, then we'll return false directly. Then what we can do, we'll traverse this whole string, we'll go character by character and check if this is a letter, because I told you like it could contain special character as well. So we have to filter that out as well. So we'll go one by one like this. Okay, one by one and check if this is a letter or not. If this is letter, then I'll put it in a set. Why set? Because we know that set has a property that it could only contain unique element. We could put it in a list, but list could contain duplicate element as well. So now after this, after checking the length of the string, how we can proceed, we'll go letter by letter. We'll go one letter by one letter. Basically we'll traverse the whole string and check if each character is a letter or not, because I told you in the note section that there could be special character as well. So we'll go one index by one index, then we'll check if that index contains the letter or not. If it contains letter, okay, then I'll convert that letter either in lower or uppercase, then I'll put it in a set. That's what the plan is. Okay, so let's put it down in here. I'll do traverse the whole sentence. Okay, check each character. If character is true or letter, then what we'll do, I'll put it in a set. Okay, I hope you understood the logic. You may raise the question, why you are using set? Because set has a property that set could only contain unique element. So that's why we are using set. So I'll put it in the set, and at the end what I'll do, I'll check the size of the set. If it is equal to 26, then what we'll do, we'll simply return true, else return false. So we can dry run our algorithm based on the same example we have taken, ABB underscore C. So let's dry run it. First of all, we have index I equal to 0. So on 0 we have character A. In 0 we have character A. So is A is a letter? Yes, correct. Then what I will do, I'll put it in the set. So let's say we have one set like this. So let's say, okay, so we'll put A over here. I'm inserting the lowercase. Okay, then let's move to the next character. Change the I value to 1. Change the A to B. Is B is a letter? Yes. Then what I'll do, I'll put it in the set. But before putting it, I'll change it to lowercase. So I'll put B. Then I'll move the third character, move to index 2. And again, this is B. Is it a character? Yes. And I'll put the lowercase of that character in the set. As set has already contained B, so it will not contain the duplicate element. So the set contains only A and B until now. Then move to the fourth character, that is underscore. It is underscore. So is underscore is a letter? No. So then I will not put it in the set. Let's move to the next one, that is 4, and this is C. Is this is the letter? Yes. I will put it in the set. So what is the size of the set? This is 3. So 3 is less than 26. That's why I'll return false. Okay, but But we can like this particular, although I have taken this example, this particular example can be disqualified by this very first statement, that is check the length of the string. For the sake of the dry run, I have taken this small example, but as the string length itself is 5, so it is less than 26. So at the very first line, we can return false. So here I have to add one more point, that is if the character is later, I'll put it in the set. So before putting it in the set, either I have to convert to lower or upper. Before traversing, we have to initialize the set as well. I forgot to mention this. So you'll also learn like this. Okay, so there is no straightforward way. You'll think in your own mind, then as you'll go along, you'll understand, okay, where I need to initialize, where I need to put another on condition. So that's how you'll learn. So here I have to initialize the set. Although I'll share all of this note in the description. Okay, you can find it. You don't need to make your own note along with this video. You can follow the video. Okay, later you can make the note. So let's code it out. We have designed our algorithm and everything. Let's code it out. So let's put our method as a public and return type will be boolean, and we could put our method name as isPanagram. I need to pass one string. As I have at very first, we need to check the length of the string. At the very first line, what I will do, if send, you can do it in any language basically. Okay, once you have understood the algorithm, you can code it in any language. There is no issue. If sentence dot length less than 26, then here itself we will return if it is greater than or equal to 26. Then what we will do, we will first initialize as per our algorithm. We will initialize the set first. So here I'm going to take one hash set. So let's say it is a set and this will contain character new hash set. Okay, we have initialized our set. Then what do we have to do? We have to traverse the whole sentence. So basically we have to implement one for loop. It will go until the sentence length is ending, and I'll increase one by one. Okay, and inside this for loop, what I'll do, check each character. Okay, so as part of checking, what we are going to do, if character is later or not. So if we have one inbuilt method basically in Java, you can implement your own as well. If you want, I could make it in a separate video, but it's pretty straightforward. Okay, if is later, okay, so sentence dot char at I. Okay, so basically it will fetch index by index. Based on the given index, it will fetch that character. Okay, so is later character I. Okay, so basically this char at a given index, it will return a character and it will just check that if it is a character or not. If it is a character, then what we are going to do, I'll put it in the set. But before putting in the set, I have to convert it to either lower or uppercase, correct? So what I'm going to do, inside this if condition, I'm converting here as a lowercase. Okay, so again I'm going to use one inbuilt method, that is character dot to lowercase sentence dot char at I. Okay, so I have added it into the set. That's it. We are done basically. We are done with our implementation. What we have done, this is our scene, is our set. So I'm adding it. So before adding it, what I am doing, I'm converting it to lowercase. So that's it. After that, what I am doing, at the end, I'm just checking if the set size is 26 or not. Okay, so let's end this for loop. After this, I'll simply return if scene dot size is equal to 26 or not. That's it. I hope you understood it. Let's proceed with the time and space complexity. You know that this particular operation is going to take a constant time, so it is big of 1. Okay, the main time is taking this one. Okay, so we are traversing each and every character and we are going at the end of the string, correct? So it's going to take big O of n, correct? Because let's say we have a sentence which has length of n, then we will go each and every character. So that's why this particular for loop is going to take big of n time. Okay, and all of these operations, we know that adding or checking anything in the set, it's going to take, basically in the hash set, it's going to take a constant time. So I can say all of these operation is going to take big of 1, correct? Again, this operation is going to take big of 1. So at the end, we can say that time complexity is big O of n. Understood? Now let's analyze the space complexity. What is space complexity? How much space it is occupying during execution of this method. Okay. What is the total space our program is occupying during execution of this whole method? Correct. That's it. So basically, if we see, we are using some variable over here, that is I. Okay, we are using I. We are using another one state called scene. And at max, how many character it can contain? It can contain 26 character. Correct. So there is no any other variable we are using. So we can say that space complexity is big of 26. So we can say that it's a constant time, because at max it can contain 26 character only. So it's a constant, correct? Because it is not varying based on the size of our sentence. So that's why we can say the space complexity is constant. Okay. So I hope you understood this. I'll share the code in GitHub and share the link in the description. I'll share this note as well. So if you have any doubt, please put it in the comment section. I'll try to clarify it. Thank you.